So that is you take any two points x, y in the domain, right? Then the ninth segment is given by this. Lambda from 0 to 1, lambda equals 0 is just x. I'm sorry, it's just y. Lambda equals 1, this is just x, right? The two endpoints. And then this is the value of f. So here this is lambda x plus 1 lambda y, right? And this altitude, this height, this level is f of lambda x plus 1 minus lambda y, right? And this one, you go further up, this height is lambda f of x plus 1 minus lambda f of y, right? Right. Y, look at this point. The coordinate of this point is x, f of x, right? And coordinate of this point is y, f of y, right? And this line has an equation that's I can't use y. I use t, u, and this I use t, right? So the u equals x, f of x, plus the slope is f of y minus f of x over y minus x times now is t minus x, right? Now x is a fixed number, y is a fixed number now, right? So which is the same as this is just this is 1 minus this of x. That's y minus t over y minus x times f of x plus x minus t and t minus x over y minus x f of y. If you call this lambda, this is just 1 minus lambda. Okay. So, and then that is the question is this, you for this lambda, then u is this. So you can see u is always larger than this value, right? That means this ninth segment is above this graph. No matter how you pick the 2 points on this graph, right? That's the definition of convexity, right? This is consistent with our notion of convexity in calculus, right? In calculus, the second derivative was like the second derivative is positive or non-negative, right? That is, the first derivative is increasing, right? So what's the meaning of the first derivative? The slope of the tangent lines, right? You look at those tangent lines. Here this is very steep, but the slope is negative, right? It's close to minus infinity, more or less, and it then gradually grows. Somewhere here is 0, and then positive, and steeper, right? Right. So that's meaning this is increasing, right? So all these definitions of convexity are consistent, right? So now, problem 24. That's okay. Go back around. So assume f is continuous on AB and satisfies f of x plus y over 2 is less than or equal to f of x plus f of y over 2. Then we want to prove f is convex. This is for any x, y in AB. So we want to prove f is convex on the open interval AB, right? Here, the important assumption is f is continuous. If f is not continuous, this is not true, right? So, before I do the proof, let me do a little bit of analysis. That's, for example, I consider this is true, this is like lambda equals 1 over 2 in this definition, right? Isn't it? Lambda equals 1 over 2, this is x over 2 plus y over 2. This is 1 over 2 f of x plus 1 over 2 f of y, right? That's a special case. So now I change this a little. I change it to, for example, lambda equals 1 over 4. So 1 minus lambda is 3/4, right? I want to say if this is less than or equal to 1 over 4 f of x plus 3 over 4 f of y, right? At least I just go a little bit further, right? See if this is true. So then this one, the left-hand side, I rewrite this as, for example, x plus y over 2. If x, y are in this open interval AB, then the midpoint is also in AB, right? So I don't need to worry about that. And then I plus y, and then divided by 2. Right. So you can say you just do the manipulation. The half of x divided by 2, that's a quarter of x. There's half of y plus y, that's 3 halves, and divided by 2, there's 3/4 of y, right? Right. This equals that, right? And this one is a number in this interval. Y is a number in the interval, so then I can apply this, right? I simply replace x by x plus y over 2, right? Right. So this is less than or equal to half of f of x plus y over 2 plus half of f of y, right? Agree with me on that? And here I apply this inequality again, right? So, because this is only true for lambda equals half, right? I only use that, right? That's the only thing I can use. So this is 1 over 2 half of f of x plus 1 over 2 f of y, and then plus half of f of y. And then you add them up. So the 1 over 2 times 1 over 2, that's 1 over 4 f of x. And then 1 over 2 plus 1 over 2, that's 1 over 4 plus 1 over 2, that's a 3/4 of f of y. Right? So you just compare this. This is true. That is, this inequality is true if lambda equals 1 over 4. Right? Yes? I want to prove this inequality is true for every real number lambda between 0 and 1, right? That's my goal, right? Here I prove for those numbers. So those numbers are special. They are just in the form. So our guess is this must be true for any integer over 2 to the m, right? Those direct numbers. So that is, this inequality must be true for the direct numbers. And how do you prove that? Induction, right? You use induction, right? Okay. So now let me just prove this, right? And then that's true for any direct number. And then how do you prove this is true for every real number? Then you just approximate the real number by the direct numbers. And because this function is continuous, you can take limit. Right. So let's just do the proof. We first prove so this is a k over 2 to the m x plus 1 minus k over 2 to the m y less than or equal to k over 2 to the m f of x plus 1 minus k over 2 to the m f of y for all this. M is just any natural number, and k is an integer that could be 0, 1, 2, up to 2 to the n. Yes? So We first prove this by induction, mathematical induction. So step one, induction on K, on K. Yeah. Induction on K. So we fix M, right? We fix the value of M, right? So then when K equals 0, this inequality is just 0 times x, that's just y. Less than equal to right hand side is just K equals 0, that's just f of y. This is trivial, right? It's trivially true. F of y less than equal to f of y. That's trivially true, right? Yes? Step 2, now suppose K is less than 2 to the n, and f of K over 2 to the n x plus 1 minus K over 2 to the n y is less than equal to K over 2 to the n f of x plus 1 minus K over 2 to the n f of y holds. So we want to prove this is true for K plus 1. We need to prove this, right? That's a setup of mathematical induction, right? So we look at this left-hand side.
Did you want to assume that K plus 1 is less than 2 to the n?
Yeah, because K is less than 2 to the n, then K plus 1 is less than equal to 2 to the n. Right? So don't worry about that now. Right? Okay, up to here, so then I can rewrite this as f of K over 2 to the n x plus 1 minus K over 2 to the n y. So that's the first one. And then plus 1 over 2 to the m x minus 1 over 2 to the m y. Let me think if that's a correct. I want this more or less, I want this. So I want to learn from something like this, right? Something like this. So that is K plus 1 equals K minus 1 plus 2. this as k minus 1 over 2 to the mx plus 1 minus k minus 1 over 2 to the my, and then plus this 1 over 2 to the m minus 1x minus 1 over 2 to the m minus 1 y. So that is this.
Oh, Professor,
Yes.
I brought another eraser for you.
I'm sorry?
There's an eraser right there.
Okay, thank you.
I don't know if it's any better.
I need to manipulate this so that I can use this assumption. It's for any k prime less than equal to k, right? This inequality should be true. So let's say I use a k prime. I use k prime. For all k prime larger than equal to 0, less than equal to k. Less than equal to k. Just change this a little, right? But for all smaller k's, this is true, right? I want to prove it for k, true for k plus 1. That's not a big deal. It's just a little generalization of in standard induction. Okay. And this one. So if I keep doing this, this would be 1 over 2 to n minus 1x minus 1 over 2 to n minus 1y. I don't want that. I want 2x plus 1. X plus 1. Suppose this is a plus this one, a plus this one.
Professor,
Yes.
can we do induction on M? I think that will be easier.
Even if you want to do your induction on M, because we need to do that, right? But you need to prove for every case this is true, right?
Yeah.
Right? So here I want to prove just to say, even for every M, you want to prove for every K this is true, right?
Yeah, but for if M equals to 0, then K can just be 0, 1. This is
Yes,
true.
that's it, that's obvious, yes. And then what? If you prove this for the general,
Yeah, and plus 1, I think is similar to your example.
okay, yeah. Let me take that. Yeah, that's a good advice.
Can I be in your study group? I'm just
Let me write it here. On N, right? So, okay. For N equals 0, I'm sorry. Let me just change my, I'm sorry. You can. That's right. So step 1. Can you see what I wrote here? I don't know how to handle this. And I went to the store, I found the same eraser as this one. It doesn't do any good, it doesn't do any better. So then, yeah, M equals 1. So if M equals 1, then you can say, you need to prove, for K. Why is it? For K equals 0, this is just f of y less than or equal to f of y, right? Just use the old traditional blackboard. Is that so difficult? K equals 0, this is f of y less than or equal to f of y, right? So if for K equals 1, then this just becomes f of x less than or equal to f of x. This is trivial, right? That's a trivial. And then step 2. So suppose this is true for this is k over 2 to the m x plus 1 minus k over 2 to the m y less than or equal to k over 2 to the m f of x plus 1 minus k over 2 to the m f of y for all k less than or equal to 2 to the n, right? So we want to prove Thank you very much. We want to prove f of k over 2 to m plus 1 times x plus 1 minus k over 2 to m plus 1 y less than or equal to k over 2 to m plus 1 f of x plus 1 minus k over 2 to m plus 1 f of y. And this is for any k less than or equal to 2 to m plus 1, right? So now the left-hand side, I can write it as f of half of k over 2 to the m times x plus 1 minus k over 2 to the m y. Well, if k equals 0, it is trivially true, right? With k equals 0, you don't have x, you only have y, right? That's f of y less than equal to f of y, right? 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 F of y less than equal to f of y when k equals 0, right? Right? So now we say if k is larger than equal to 1, so then the left-hand side I can write it as f of so this plus that. Okay, I'm sorry, this is not 1, this is 2 now, right? All right, this is 2, right? Right, this is 2. This is 2, because I take the 1 or 2 out. So then this plus this equals 2, it's not 1, right? So now this equals, I can change it to k over k over 2 to the m x plus